This last video that we have for 227 is a really short one. So we're going to look at one of the organs of the endocrine system, and that's the pancreas. If you look over here at this diagram, we have an artist representation of a pancreas. So it's a part of the digestive system. That's another one of its roles. And just to orient you a little bit, right here, so kind of above it and sitting in front of it, is normally where the stomach would be. The artist has removed that from this particular diagram so that we can focus on the pancreas and see the structure of it. So I mentioned that the pancreas, in addition to being an endocrine organ, is also considered to be a part of the digestive system, and it has an exocrine function in the digestive system. You may remember that the difference between endocrine functions and exocrine functions is whether or not a product is secreted into a duct. So if you look at this picture of the pancreas, you'll notice that represented in yellow here, there's a pretty extensive duct system. And these ducts are there in order to allow digestive enzymes that are produced by the pancreas to be released into the small intestine right here so that they can help with the breakdown of foods. So again, that's our exocrine function of the pancreas, and it's exocrine because those digestive enzymes are released into ducts that are sitting on the outside of the pancreas. The pancreas also has an endocrine function, and you'll remember that when we're talking about an endocrine organ, this is an organ that secretes a chemical, it secretes a product that gets picked up by the bloodstream. So it's not released in ducts and transported by ducts to where we need it to go. So the pancreas also has an endocrine function as well. It produces a couple of hormones, glucagon and insulin, which help us to be able to regulate blood sugar. I want you to focus for a minute on this small little part of the pancreas right here that's boxed out, and then look at this part of the diagram here. So this is an artist representation of pancreatic tissue under a microscope. And there's a few different kinds of cells that make up pancreatic tissue. So first of all, we've got these cells here that are represented in kind of this tannish, brownish color. These are the cells that produce and release digestive enzymes for the small intestine. And you'll notice that those cells have a duct into which they're secreting their product, which is going to join up with some of these larger visible ducts and transport those digestive enzymes again to the small intestine. But you'll also notice that kind of separated off by themselves, we have these cells that are represented in purple, which are known as pancreatic islet cells or islet of Langerhans cells. These are the cells that produce glucagon and insulin, and you'll notice that they are not hooked up to a duct system. Instead, they've got a pretty vascular structure with lots of blood vessels that run through them. So these little purple cells in here that are representing the islet cells, they can secrete, they can release insulin and glucagon just outside of themselves, and those hormones get picked up into the bloodstream and transported to where they need to go to their target organs where they can have their effects. Just a little bit about glucagon and insulin. I think most people are pretty familiar with insulin because we have such a diabetes crisis in our country right now. Insulin is there to decrease blood sugar when it gets too high. So after you've eaten a meal and you start to have the carbohydrates from that meal broken down and released into the bloodstream, we need to be careful with how much that spikes the blood sugar, particularly if it's going to keep blood sugar high for a long period of time. Because when the blood gets a lot of sugar in it, it actually becomes a little bit thicker and a little bit more syrupy, and that can be really damaging to the blood vessels of the body, which can then lead to damage to all other tissues of the body. So it's really important that we keep our blood sugar from getting too high and staying too high for too long, and insulin is the hormone that allows us to be able to do that. It causes sugar to be taken out of the blood and put into cells of the body. The flip side of this is what glucagon does. So glucagon prevents our blood sugar from becoming too low. Blood sugar that's too low is also problematic because remember, the cells of our body are using glucose in order to be able to make ATP. So you'll start to see effects, cells not being able to do what they need to do if blood sugar is getting too low. And so we need to have a way to prevent that from happening as well. We need to keep blood sugar levels within a specific range. So glucagons are a hormone that's released when blood sugar levels are starting to get too low. Think about in the morning when you've gone all night without eating and you've been fasting for maybe 10 or 12 hours before breakfast. This would be a time when glucagon's being released. And what it does is it causes glucose that's stored in the liver to be released into the blood to prevent blood sugar levels from becoming too low.